Okay guys, so welcome to this really small tutorial on OpenCV. So first of all, I need to tell you that we won't cover the whole library on this tutorial, and it's basically meant to show you that it's easy to use and how to start up using the library. Before we start, so small words on the library itself. So there is no real concepts for this library, so there's no real theoretical background for the library itself. So it's not something that you can say, I know OpenCV, but perhaps you might say, I know how to use OpenCV. So OpenCV is just a library, and then you shouldn't get too frustrated or too excited with the library itself. So as any other middleware, it's just a way to facilitate how to work with computer vision and with computers, right? So it's just a library, and then take it as it is. It's one of the most popular libraries for computer vision. So now the story changed a bit since deep learning came into the game. But if we forget about deep learning for a moment, then OpenCV is the most widely used computer vision library, and it's fully open source. It's supported by many companies and researchers all over the place. So this is a library that you will be using for your final project. Yeah, so let's see some small concepts about the library, and then I will give you a link to Igor's explanation on this library that is much more extensive. So if you have any doubt, you can go and check that video, but that will be about 40 minutes, and we will try to keep this no more than 10 minutes. So OpenCV is a popular library for image processing. We are using version number 4 of OpenCV. Has been released not too many ago, and the reason of why we're using this version is because this is the first version of OpenCV that fully supports C++11 compilers, that is supported by these compilers, and also it's a much more C++-like library. So when they started developing the library, it was much more like a C-style library, and they are switching to C++ because it's just better. We will be using just a really small part of it, and when I say a small, it's basically less than 1% of the library. How to access all the functionality of the library is just including this header file. So if you go and check this header file, basically inside will have like multiple include statements. All the functionality will be under the namespace CV, and there's much more information on OpenCV, right? So the only warning is that nowadays everyone is trying to use OpenCV with Python, and you will be using OpenCV with C++. So make sure that if you watch any tutorial of whatever, make sure it's on C++. So the ideas are the same, and the functions are actually the same. And they're all implemented in C++, and the Python is just a wrapper to call these functions in C++. The only complicated thing about OpenCV is that in order to make it run fast for you, they use their own types, and the problem is that they trust you to use the right types. So the type safety, let's call it, of OpenCV, it's not great because they want to make it fast for you. So they trust you to use the types, and if you don't use the right types, then you will most likely suffer. So the names are usually following this pattern. So it's CB and then underscore and then the bit count of the type, the identifier, and the number of channels. So for example, in this case, let's highlight it. So for an image, for a classic RGB image, we will have the first part of the type will be CB, that is basically this. Then the bit count is how many bits will be representing this type. In this case will be 8, so it's 1 byte. And then the identifier is going to be unsigned character in this particular example. And then the number of channels is going to be the last part of the type. In this case will be 3, right? Okay, so the coloring didn't go so well. So an RGB image is going to be CB underscore 8 bits, unsigned char, and then 3 channels, right? And then if you want, for example, to represent a grayscale image, will be the same type, except that you will be using 1 channel, right? so you will change the last number. Perhaps you might want to use data type. So this is basically just an alias for this type of OpenCV types, and this is one example, but it's basically up to you. Then, so that's the most condensed history about data types in OpenCV. Then the most important class in OpenCV is going to be CVMat, that stands for matrix. And then basically everything on OpenCV will be a sort of a mat, right? So images will be matrices, descriptors, and so on. So if you want to create a new CVMat, for example, this is one of the constructors you can use. So in this case, you will need to specify the number of rows, the number of columns, the data type, and then values. And then also you can use this templated type that you basically, instead of providing the type in the argument, whenever you create the image, you provide it here. So it's basically the same, right? And then this is a small example how to create a matrix, 10 by 10 matrix with all zeros. And then in this case, we declare like a matrix called image of type CVMat, and then we will call this utility function called zeros, and then here we specify what the rows and the columns, that is basically 10 by 10, and then the type. This will create actually 3 matrices behind the scenes, because it's an 3 channels inside car, so it's going to be an image full of zeros. Then you can do some type aliasing to make your code more readable. So for example, you can use matf and then to access a matrix of floating point values. And then you can do the same, but remember, as we saw here, so in this case we're specifying the type here, so we're saying this is float. And then instead of doing it on the constructor, then we don't need to specify this anymore. So this is going to be one matrix of 10 by 10 full of zeros, but on floating types, right? If you want to get the type of the image, you can use this member function that is called type. Also, you can get the size with rows and columns, and there's much other methods for the class. And then from input-output perspective, you will be using sort of 3 methods. There is image read, that is to read an image from the, let's highlight it here, from the file system. And then you have image write, that again will write an image to the file system, and image show is going to be a function to show you the image on the screen. Then one big disclaimer is that CVMat is a sort of share pointer. So when they started developing the library, all the memory management, dynamic memory management libraries from C++ were not in place, so they had to do it by hand. We will discuss this on future lessons, but just a warning. So CVMat, so the warning is actually here. So let's say you have this image, and then you create a CVMat, and then you will create another image. Whenever you do this, you will not copy the content. So if you access then image no copy, you will also access the original image, right? So this is just a warning. You will get much better understanding on this topic in future lessons, but just keep in mind that whenever you do this type of assignments, you're not copying the data. Then how to read an image? It's really easy actually. So the only thing you need to know is sort of the codec of the image, and then there are many of them on OpenCV, but the 3 most widely used is image read unchanged. That is, okay, whatever you have on the image, you can read the image as a grayscale, or you can read the image as a color. And these are like basically the integer numbers behind the type. So all these types are basically integers, or basically they're replacing a number. And then if you want to read an image, for example, logo opencv.png, then you just call image read, that is under the namespace cv, and then you specify how you want to read it. So if this is a colored image, and then you say unchanged, you will see a color image. But if you, for example, do grayscale, then you will only load the grayscale values, right? Writing is as trivial as reading, so instead of calling CV image read, you need to call CV image write, and actually there is a typo here, so sorry, this should be image write, not image read. So this is run on the slide, and then you specify the file, and then which is the mat you want to write. And then just another warning with floating point values images. So if you want to store for some reason a floating point image, you should be using EXR files. So if you use PNG, I highly recommend you to try the example, and you will see how weird it is. But basically there will be some compression, and you will be losing some information from the floating point values, and then this format EXR will guarantee you that you don't lose any information on the values itself. So when you write the image to the disk, then you don't lose information if you read it. So there's a small example here. So try to happen if you use PNG. So basically copy paste this example, and then instead of using EXR, just put PNG and then open the image. So actually when you write it to the disk, you can just double click and open the image, and you will see all the errors. Image show, it's basically the utility function to show an image to the screen. So it's actually quite easy. The only thing you need to be aware is that you will need a window. So the first thing you will create is a window, and then here you will put the name. In this case we pick window name, so it's a really smart name. And then you want to pick the auto size function, the type, sorry. So the size of the image will be the same of the window, and then you just call image show, right? And then you say which is the window name, where you want to put this image, and then the image. That is basically a CVMat. And then with this trick, with CV wait key, you just open the image until the user presses a key. So this is easy. Again, all this is, so there's no real concepts behind like showing an image on the OpenCV library. This is how you do it with OpenCV. If you're using other library, the functions will be other ones, but the concepts are the same. So you should not get really excited about the library itself. It's just a tool for you to make your life easier when working with images. So there is also a vector type. Here's an example. We will skip this, and the last warning is that mixing up types is painful. So OpenCV again trusts you to pick the right type, and this can cause errors if you don't use it correctly. And then OpenCV interprets bytes stored in CVMat according to the types that the user asks. So basically, inside the CVMat there will be an array full of data, and then depending on which type you say you're using, it will give you the information in this array. But if you, for example, if you have, I don't know, 2 bytes in there, and then you say, okay, my type is byte by byte, then you will get 2 values. But if you say my type is 2 bytes, then you will get only 1 value. The information is the same, but the organization is different. So make sure you're using the correct types, because there is no safety when mixing these types. Again, there's one example here. The recommendation is go and check it out, try it on your computer. Okay, so we will not cover SIFT descriptors on this small tutorial because I really want to keep it short. But there's basically, this is the most popular scale invariant feature transform. So this is widely used, is one of the most, if not the most cited paper in computer vision, and this is really widely used in our community as well, so for robotics. And you will be using it for your final project and also for homework number 5. How we do this with OpenCV? Again, the SIFT idea, so how to extract SIFT key points and descriptors it's an idea. So there's some theoretical background in there that has nothing to do with OpenCV. So SIFT is not something that belongs to OpenCV. OpenCV is a library, and they decided to implement these ideas with some functions and whatsoever. So you can use SIFT, you can write your own SIFT implementation. There are another SIFT implementations out there. OpenCV it's just a tool to give you the implementation and to speed up your development. So don't get confused with OpenCV itself. It's just a tool to allow you to use Sift, but it's not. So it's really important that you understand how to use Sift key points and features and what they are, and not like what is OpenCV doing with this or how they implement it. So the idea is more important than the library. So how we detect key points, so it's really straightforward. The syntax is also good. So you will create a Sift feature detector. You will call in this function create, and then this is how you get your detector. And then you will create a vector of key points. We will name it key points, and then with this detector you will pass an input image that can be any image of that you like, and then the key points that is basically this vector to be populated. And then if you want to display these key points, the Sift key points on the image, then you need to create a new image. We will call it image with key points, and then we will call this function that is called draw key points. This is the input image, this will be the key points, and lastly this is the output of this method, right? And how to extract the descriptors. And instead of using a feature detector, we will use the descriptor extractor with the same syntax, and then we will compute this on the image, on the input image with the given key points, and the descriptors will be the output. So this is not the best syntax of C++, but in order to maintain backwards compatibility, they did it this way. So it's easy, syntax is easy. There's also one example here on how to use flan. There is also one on the example project, and I will just skip it to keep it really short. So what you should do after watching this really small tutorial, you should go and check it out, that link. There is one example OpenCV. There's another typo here, sorry. So this should be 4, like here on the title, and not 3. And now we will build this example, so you see that it is actually really easy. So after watching the tutorial, go and check this link. So on the README there is instruction on how to install the library, and there is some small examples, right? Much more additional information on the OpenCV documentation, and then that's basically it, guys. So let's run a really small example now. So let's, for example, do examples, take OpenCV, right? And then for this we will create a main.cpp file and then a CVMap lists file, and then that's basically it for now. Let's open this Visual Studio Code. And then let's start coding. So let's make this bigger. Okay, project, OpenCV example. And then CVMap minimum required version is version 3.1, let's say. And then for now, let's do like a hello world example. So add executable, and then main, let make.cpp. And then here, let's this, and then include IO stream. And here, just hello world, and then return 0, right? So with this we kind of make sure that everything is working. So we can do CVMap dot, for example, keep it simple and make it, right? And then we just do make main, and it's working. Okay, now it's time to get OpenCV functionality onto the project. How we do this? So if you check for on the slides, the most important thing, so include OpenCV is to do find package, and then for this you will need to say, okay, OpenCV was like this, and then version 4, and then you will do require. with this you are telling CMake that you should be using OpenCV4, so it will look into your system wherever it might find it, and this is required for the project in terms of, okay, you need to have this package, otherwise it would fail to build. So if we do CMake now, everything is working, but let's say we have a typo here, or like missing library, let's call it library, and then if we try to run CMake now, this should fail. Why? Because it says, okay, missing library is not there, whatever. So at this point, if you have an error, so do it step by step. So first do the hello world example, and now try to find the package. If you have an error here, it's because there is an error on your installation. So in this case, we see this message that says found OpenCV on /user local, and then the version is 4.3, and the minimum required version is 4 because we say version 4, right? And then so far we didn't do anything crazy, but one thing we need to add here is, okay, we need to say include directories and then specify the OpenCV directories, that in this case OpenCV, and then include dirs. So this is basically where all the header files are on the for OpenCV. And then if we want to use OpenCV functionality, we also need to link against these libraries. So you know how to do this is target link libraries, and then we will link main, again, this variable from CMake that is called OpenCV, and then the name is, let me check, I think it's libs, like this. So the example is here for you, so you can check all these names. We are just building a really small example right now. So make sure you go and check it out, the example on the GitLab server. Okay, so it's OpenCV libs. Yeah, that's correct. And then for now, let's display an image. So let's just CMake this and make. So there's no difference so far because we didn't do anything with the main function, right? But if we go back to main, then we can start using OpenCV because now our build system is working for us. So we can do OpenCV2, for example, and then one thing you can do is to just include everything. I actually like to include only what is needed. So, but for now, let's do it like this. And then instead of hello world, let's call this hello OpenCV, right? And then first of all, we will create a CVMat, and then we'll call this image, and then we are going to read an image from the disk. And then how to do this, we will just call CV image read, as we saw before. And the file name of this image, it will be Lena, so most widely used image. And then we need to specify how we want to read it. So for now, let's do it with grayscale. So image read, and then here you're gonna pick grayscale, and then that's basically it. And then now it's a good idea to check that this image is not empty, so that the read was successful. So if image is empty, then we will do CError, and then we'll say, okay, image not found, and then return 1, right? So if we build this example now, this should work, but you will see this error that say image not found. And if you ask the prompt, you will get the error code, right? So now let's pretend that we have the image, so we skip this step, and then we want to show it. So we will create a string, and then window name, let's call it Lena, and then we will create a name window with OpenCV, and then window name, and then lastly image show, and then we want to do it on this window and then this image, right? And to see the image on the screen, we can do CV wait key, and then the delay is going to be 0. And with this, we will wait until the user press any key. So that's the most simple example you can do. If you make this, again, you don't have the image, so you will say not found, but let's copy the image, and now it's on. So on the example OpenCV, it's on image. So now the image is here, and then if we run main, we should see the image here, right? Oops. Okay. Let's examples. This doesn't work well with i3 window manager, but that's basically the most simple example you can think about. So if we run main now, okay, the thing is I am pressing a key, and that's why. So if I press a key here like space, then you will close the image because of this. But with this, you know that the OpenCV library is working. So this is the most simple example you can think about. And if you go to the example I told you, so this example OpenCV, so here you will find how to install the library. So make sure you go through all these steps. And then if you struggle, let me know. I will try to help you. And here under the source directory, you will have 3 apps, so 3 applications. One is to display the image. That is basically the same thing we just saw. Other one to compute shifts and display it on the image. So there is another example here that will be using a library, like a really small utility library that we call it shift compute. That is on here. That this is basically the example you can start building upon to compute shift features. So that's basically it. It's super easy to use the library. So make sure that if you don't understand, I will link you with to the Igor description of the library. It's much more detailed. But the only thing you really need to know at this moment is to install the library, to build the examples, to make sure that it's working on your system, so you can use it for homework number 5. So that's basically it, and thank you for your attention.